Okay, this will be the first of two videos kind of to prepare for the exam on Friday. The first topic we're going to go over is solving absolute value problems. Basically problems where there's an absolute value involved with the equation. And one of the things that we have to realize is that we have to eliminate these absolute value signs somehow. And to solve for x, we have to get x by itself, which means we have to get rid of the 4, the 2, the 7, and the absolute value signs. We can't forget that. The method to get rid of the absolute value signs is to first isolate the absolute value. Whatever the problem says, get the absolute value by itself. So I'm going to first subtract 7 from both sides, and that's going to give me absolute value of 2x minus 4 equals 8. And what we've done now is we've done the most important thing, which is the absolute value, to isolate the absolute value. So the absolute value is by itself on one side of the equation. At this point, to get rid of the absolute value sign, we have to write two equations. And what that means, really the reason is because this entire thing here is going to be a number. If that number is the same as 8 minus 4, if that equal to 8, then this would be absolute value of 8 equals 8. Also, though, if this entire thing that I circled here is equal to negative 8, then that would also be true because the absolute value of negative 8 is 8. Now, some people just kind of remember I write two equations, and that's true, but this is the reason. So now I just have to solve each problem like an 8th grader. So I add 4 to both sides. 2x equals 12, divide by 2. X equals 6. So that's one solution, x is 6. The other one over here, I'm going to add 4 to both sides. I have 2x equals negative 4. Divide by 2. X equals negative 2. And whenever we have absolute value problems, we want to check to make sure they actually do work. So if I plug 6 in, we're going to check 6. And the method of checking is to take the x and change it to each of those numbers, in this case 6. So that's going to be absolute value of 2 times 6 minus 4 plus 7 equals 15. And we're kind of checking to see if that's true. So that becomes the absolute value of 12 minus 4 plus 7 equals 15. Absolute value of 8 plus 7 equals 15. Absolute value of 8 is 8. 8 plus 7 equals 15, and that's true. So that means this is one solution. When we try negative 2 into the equation, I'm going to do the same thing over here. I'm going to say absolute value of 2 times negative 2 minus 4, absolute value plus 7 equals 15, and we're checking that one. Absolute value of negative 4 minus 4 plus 7 equals 15. Absolute value of negative 8 plus 7 equals 15. 8 plus 7 equals 15, and that also is true, so there are two solutions to that problem. Okay, we look at the next one. It gets a little trickier in that we have this kind of weird situation right here. So the principle is still the same. We have to isolate the absolute value sign, which in this case, it already is isolated. So now we go on to the next step. We have to get rid of the absolute value signs. We're going to write two equations. One where this entire thing inside of here, x minus 2 over 4 is equal to 6. Another one where x minus 2 over 4 is equal to negative 6. Because this whole thing in here could equal 6 or negative 6. Now when I multiply, to simplify this, I'm going to get rid of the 4 first. So I'm going to multiply times 4 on both sides. And that becomes, these are going to cancel. And I'm going to get x minus 2 equals 24. Add 2, x equals 26. Over on this side, I'll do the same thing. I'm going to multiply both sides by 4. And these are going to cancel. I'm going to have x minus 2 equals negative 24. So now when I add 2, I get x equals negative 22. So those are two answers that we need to check to see if they work. We'll check 26 first. That's a check 26. So that's going to be absolute value of 26 minus 2 over 4 equals 6. And that's what we're checking to see if that works. 26 minus 2 is 24. 24 over 4 is 6. Absolute value of 6 is 6. So 26 checks out. Let's try negative 22. Absolute value of negative 22 minus 2 over 4 equals 6. Negative 22 minus 2 is negative 24 over 4, which is negative 6. The absolute value is positive 6. Both of those answers work. All right, we look at the next one now. It's going to get a little trickier because the x is over here. When there's an x on the other side, we have to, it's a little bit trickier. We just have to make sure we check our answer. So, but the concept is the same. We isolate the absolute value. So I have to first get rid of this 3. So that becomes absolute value of x plus 6 equals 2x plus 3. I can't combine them because one has an x, one doesn't. Okay, the principle is still the same. It's just going to be harder work or more complicated work. So now this thing inside of here could be exactly the same thing as 2x minus 3. So I have x plus 6 equals 2x plus 3. Or x plus 6 could be the opposite of 2x minus 3. Now the opposite of 2x plus, actually, opposite 2x plus 3. The opposite is 2x plus 3 would be negative 2x minus 3. And now I solve each of these problems. So there's a couple of methods to do this. I'm just going to get all the x's on the left side. So I'm going to subtract 2x from both sides. That becomes negative x plus 6 equals 3. Subtract 6 from both sides. Negative x equals negative 3, so x equals 3. That's one possible solution. Over here, I'm going to add 2x to both sides. So I get 3x plus 6 equals negative 3. Now I subtract 6 from both sides, and I got 3x equals negative 9. So x equals negative 3. So I have positive 3 and negative 3 as solutions. I want to check to make sure which ones work, if any of them. So we go through the steps. We'll do the first one. I'm going to check negative 3. Actually, I'll check positive 3 because that's the first one. Checking 3 to see if it works. So that's the absolute value of 3 plus 6 minus 3 equals 2 times 3. And I just go through the steps now. Inside the absolute values, that's the absolute value of 9 minus 3 equals 2 times 3 is 6. So 9 minus 3 equals 6. That checks out. So 3 is a solution. Negative 3, we're going to check negative 3 right now. So I'm going to say absolute value of negative 3 plus 6 minus 3 equals 2 times negative 3. Hopefully you can read that. Okay, so that's going to give me absolute value of 3 minus 3 equals negative 6. So absolute value is 3, so 3 minus 3 equals negative 6. 0 equals negative 6. It does not, so this is not a solution. So there's only one solution to do there. There's only one solution in this problem, 3. Okay, a little tricky there. Sometimes they both work, sometimes neither one works. In this case, just one of them works. Now we're going to work on solving and graphing absolute value inequalities. So now we have inequalities. We're going to do similar stuff with two equations, but first I'm going to look at how we graph this. Well, basically, the absolute value of x is less than 4. We've got to get rid of the absolute values. We're going to write two, in this case, inequalities, not equations. But x, the first one is if x is positive, x is less than or equal to 4. That's all we're going to say. Now, the other thing, or x is greater than or equal to negative 4. So what we do is isolate the absolute value, just like before. We write two equations, or in this case, inequalities. And the first one is just as it's written without the absolute values. The second one, we change the right side to negative, and we change the direction of the arrow. What's going on here? So the arrow was to the left, the second one goes to the right, and change the sign here. So to graph that, I want all the numbers that are less than 4. So it's no, closed circle because it's less than or equal to. With this line underneath, it becomes closed. If it were open like this, then it would be an open circle, but we don't have that. So less than 4 is everything this way. I don't want to do that. Everything this way, forever. Greater than negative 4 is everything this way, greater than or equal to this way. So basically it has to be both of them, and so that's just going to be everything inside of here. And that's what the graph looks like. So we're going to kind of look at the next problem and say, can I get this problem to look like the last one, where I have x is greater than or x is less than. So same procedure we had before. We're going to get the absolute value by itself. So subtract 4 from both sides. Absolute value of x minus 2 is greater than 3. Now I have to get rid of the absolute value signs. I'm going to write two equations or two inequalities. X minus 2 is greater than 3, or x minus 2 is less than negative 3. So to solve this, we're going to basically get rid of this 2, add 2 to both sides. X is greater than 5. In this one, we're going to add 2 to both sides. X is less than negative 1. Now these problems have open circles because there's no line underneath here. X is greater than 5 is everything out here. Open circle going this way. X is less than negative 1 is an open circle going this way. Now there is kind of a shortcut that I'll show you a little bit, is to tell whether the lines go like this, or if they go like this. So to tell what it is, basically what happens is if we have an x or something, an absolute value of x is greater than something, it goes outward, away from 0. And this would be the absolute value of x something is less than a number. If it's less than, it's going to be in between here. Greater than, it's going to go out that way. That's kind of a shortcut that can help us. Now we're just going to simplify terms. Basically, we have to work on our subtraction. Now, what I suggest for this, a lot of people try to do everything in their head. My suggestion is take your time and write the whole thing without parentheses. And now, if there's nothing in front of a parentheses like this, they don't really have any effect. So 5x to the third. Let's make that better so we can read it. 5x to the third plus 4x to the second minus 7. And then this side is going to be, the negative is going to distribute. Minus 6x to the second. Negative times the positive is minus 3x. Negative times a negative is plus 8. And now what I want to do is combine like terms. So I look at this and I say x to the third. That's an x to the third. There's no other x to the third, so I just write that down. X to the second. So there's one here and there's one here. 4 minus 6 is negative 2. So negative 2x to the second. The next we have our x's, and that's these guys. And there's only one of them, actually. minus 3x. And then the last one is negative 7 plus 8, which is plus 1. So that's the final answer to that problem. Okay. Next problem I'm going to do is this one right here, working with complex numbers. What we do with complex numbers, that involves I. So basically we're going to do something like this. Now, the secret to working with i's is treating the i's just like we did x's. The only difference is when we get an I squared, we just make that negative 1. So for this one, I'm going to say 3i times 4, which is 12i. And this one, I'm going to say 3i times 5i, which is minus 15i squared. And now I don't stop here. I look at I squared as negative 1, so that's going to be 12i plus 15, because minus 15 times negative 1 is plus 15. And when I write that as 15 plus 12i. Okay. Next problem, we're going to just do our old-fashioned FOIL. I'm going to do it this method. 5 times 3. 3 times 5 is 15. 3 times negative 2i is negative 6i. 4i times 5, that's plus 20i. And 4i times negative 2i is negative 8i squared. And now we simplify. Take our steps and just go to simplify. These two combine together. So that's 15. Negative 6 plus 20 is plus 14i. And then this one here, negative 8 times I squared. I squared is negative 1, so that's going to be plus 8. And now I can combine my like terms. These guys combine together to be 23 plus 14i. And that's what we leave for that one. Okay, almost done with this first video. I see an I in the bottom of a fraction, and that is not allowed. We can't have that. So what we have to do is eliminate this I somehow. To do that, we're going to multiply the top and the bottom by the conjugate of 2 plus I, which is 2 minus I. So the top of the fraction is basically just multiplying 3 into both of those numbers. 3 times 2 that's going to be 6 minus 3i on the top. And the bottom is going to be 2 times 2, that's 4. Then I got minus 2i and then plus 2i and then minus I squared. So that's going to be 4, and then these guys are going to cancel. Minus I squared is negative 1, so minus negative 1 is plus 1. So the bottom of my fraction is 5. Sometimes the answer will be left in this form. Usually what we want to do is write this as a fraction. 6 over 5 minus 3 over 5i. And that's how we would write the answer to that one. Okay, the last topic is going to be simplifying expressions with exponents. Okay, to do that, we're going to look at this and say, okay, we have basically, we can do a couple things. I would suggest at this point we're going to add exponents. So that's 2 times x to the negative 3 times 3 is 9. Y to the 4 plus 5 is 9. So now I can multiply 2 times 3, that's 18. X to the negative 3 goes to the bottom of the fraction as x to the positive 3. And then y to the 9th. That's a y. Nice. Not a very good looking y. Let's make that better. Y to the 9th. That's kind of what we have here. That's what the answer should look like. Okay, so we have all positive exponents combined together. Next one, something like this, looks a little tricky. We have it in fraction form. My suggestion for this, when you have fractions with negative and positive exponents, there's a couple of ways to do this. My suggestion is to rewrite everything. Just if you have a negative exponent, we're going to move it from bottom to top or top to bottom, depending. So this 2 is going to stay where it is. x to the negative fourth goes to the bottom as x to the positive fourth. Y to the fifth is going to stay on top. Oops, let me make that better. So this is y to the fifth. Now we've taken care of the 2, the x to the negative fourth, and that. Those are all in where they go now with positive exponents. The 4 is on the bottom. It stays on the bottom. X to the 6, that's a positive exponent. That's another x to the 6th. And the y is y to the second. And now I've got rid of all my negative exponents. And now I have to do some simplifying. Now there's a couple of ways to do this. The easiest way I've known is to look at the fraction first. Can you reduce this fraction? The answer is yes. Divide by 2, we get 1 over 2. So this is going to be 1 on top and 2 on the bottom. Now we're going to take care of our x's next. There's our x's. They're all on the bottom. So 4 plus 6 is 10, x to the 10th. The y's, we have a mixture, some on top and some on bottom. So I always ask myself, where are there more y's, on the top or the bottom? And the answer is there's more on top. And the question is how many more? And there's 5 on top and 2 on the bottom, so that's 3 extras on top. So y to the third on top. And that's the answer we're going to see. Maybe you don't have the 1 there. That's not necessary. And the last one I want to go over is this one with the parentheses. So the first step is to deal with this parentheses, and the 2, basically what this means is, come on, this is not right. What's going on here? 2x to the 5th. Oh, come on, something's happened with this one. 2x to the 5th. Okay. Let's do something here. Hold on a second. I'm sorry about this delay here. This is, okay, 2x to the 5th times 2x to the 5th. That's what 2x to the 5th squared is. Now, that would be 4x to the, add the 5 and 5, and that gives you 10. Now, some people would have done it that way. Others would have said this 2 can distribute. When you have multiplication, it does. Addition or subtraction in the middle would not be able to distribute the 2. In the multiplication, we can. So this is going to be 2 to the second in x, and we multiply 5 times 2 and get 10. But 2 to the second is just 4. So 4x to the 10th, and then I have 3x to the 4th. So now I can multiply 3 times 4 and get 12. X to the 4th times x to the 10th is x to the 14th, and that's the answer we're looking for. Okay. That's all. I'm going to take a little break now. I'll get another video a little bit later, but right now these are problems you should work over. Okay,